Okay, so we're going to be working with our angle addition postulate and angle bisector foldable. So let's start with the angle addition postulate at the top. The definition says that if K is the interior of angle HIJ, so K is this point and it's in the interior of this big angle. So it's somewhere inside it, not on the edges. It does not mean it's halfway. So it says if that's the case, then, and I would really suggest you use a highlighter, let's color code this a little bit, angle HIK, that's this angle right here, plus angle KIJ, that is this angle right here. It does not mean they are equal, so I'm going to put two arcs on that one just to show. So the yellow angle plus the kind of purpley angle equals angle HIJ. So it equals the whole thing. So basically, one angle plus the other angle equals the whole angle. All right, let's try an example with that. So here's our example. So we know by setting this up that this angle right here, so I'm going to call that the measure, the little m means just measure, of angle AOB. You always use it when you're adding, subtracting, multiplying, dividing, any calculations. The m just means measure. So the measure of angle AOB, that's this one right here, plus this angle, that's BOC, equals the whole big angle, which is AOC. All right, so what we know here is we know measure of angle AOC is 70 degrees, so I'm going to put 70 right there. The measure of angle AOB is 1/2 times the quantity 2x plus 20. And then the measure of BOC is x. So now from there, that's all the geometry part. That's what we learned today is the angle addition postulate. What's left is just solving, which is really an algebra 1 problem. So what I'm going to do is first I'm going to simplify those parentheses. So I'm going to do 1/2 times 2x, that's just 1x. 1/2 times 20 is 10. I still have x and I still have 70. So I'm going to combine like terms. The x plus the x is 2x. So now you can show the subtracting 10 or you can just write out the next step. In geometry, we already expect that you've learned, how to show divide by 2. So feel free to, but you can also just go from one step to the other and I will know you subtracted 10. So you still show the steps, but you don't necessarily have to write minus 10 on both sides unless you just like to. So I get x equals 30. So now angle BOC was x degrees, so it's just 30 degrees. Angle AOB was 1/2 times 2x plus 20. So just plug your x right in there and type it in your calculator. So my x is 30, so 1/2 parentheses 2 times 30 plus 20. So just type it in and I get 40 degrees, which is good because originally we knew the whole angle added to 70, and 30 plus 40 is 70. All right, let's learn about angle bisectors. So we already learned about segment bisectors previously. And remember, a segment bisector just cut the segment into two congruent parts. So the segment bisector, you have this angle WXY. All right, the segment bisector is always, when it's an angle, it's always a ray. So a ray is what bisects an angle. It's this ray right here. So remember, when it bisects, it means cuts into two equal parts. So if it's an angle, it cuts into two equal angles. So that tells me this angle and this angle are equal to each other. So I know that if this, they said, was an angle bisector, they have to tell me that it is. So since they said ray XZ is an angle bisector, then I know angle WXZ is congruent to angle ZXY. I also know their measures are equal. So this is another one of those funky labeling things we'll just have to get used to. But when we're doing congruent symbol, notice I didn't put the M, but when I'm doing equals, I have to use the M for measure. So definitely write that down in your foldable. All right, so let's work our way through this example. It's a little tougher because there's a lot going on in the explanation. So first of all, FG, ray FG, that's right here. You should highlight that or something. Ray FG is bisecting this angle EFH. So right here, it's bisecting EFH, so this angle. So what that tells me, since they said it's bisecting, it tells me that this angle, EFG, and this angle right here, GFH, go ahead and erase that real quick, are equal or congruent. Since I use the M's, I need to put an equal. So GFH. So now they also tell me GFH is half times 10x minus 20. Good to know. And EFG is 3x plus 25. So from there, I know they're equal because it was a bisector, so now I can solve for x. So first, I'm going to distribute the half. So I'll get 5x minus 10. I'm going to move the x's to the same side. This right here is what we're learning in Algebra 1 right now, so you definitely learned it last year. So we get 2x minus 10. Now I'm trying to isolate the variable, which means get x by itself. So I add the 10. I'm going to scoot over here real quick. And to get x alone, I divide by 2, and so I get 17.5. Now, it wants us to find GFH. So keep in mind, GFH is this formula here, half parentheses 10x minus 20. So you're going to plug in 17.5 into that formula and plug it in a calculator. And I get 77.5, and it's talking about an angle, so I need to put degrees. Now, same thing with EFG. You had the formula 3x plus 25. So just plug 17.5 in for x, and you get 77.5 degrees. That's a good check because if it bisects, it should be equal. And so that means that the two angles are equal to each other, which checks out. It's a good thing. Now, EFH is this whole highlighted yellow angle. So the yellow angle, you're just going to add the 2. And when you add them, you get 155 degrees. So last but not least is IFE. That's this angle over here. Now, I'm just going to tell you, that is not drawn to scale. So don't just assume anything from that. So what I do know for sure is that this angle right here is a straight angle. That's 180 degrees. So 180 degrees minus 155 degrees is what's left, and that's 25 degrees. But we will practice with that more in just a minute. Okay, so let's look at our notes on 1.5 notes day 2. So this is example 4a. It says, given that measure of angle LKN is 145 degrees. Now notice LKN is this whole angle. It's 145 degrees. It wants us to find angle LKM, that's this angle here, and angle MKN, which is this angle here. Now we do not know that the two smaller angles are equal. It did not say the words bisect. It didn't say any clue words that give us anything else. So all we can do is angle addition postulate. So the angle addition postulate says that angle LKM, the left one, plus the angle on the right, MKN, equals the whole angle, which was LKN. So now let's fill in what we know. LKM is 2x plus 10. MKN is 4x minus 3. And then LKN, they told us, was 145 degrees. So now the setup is geometry. So that's using what we learned from our foldable. The solving is really Algebra 1, so we should be pretty good about that by now. So we combine like terms. Now we're going to subtract the 7. So we get 6x equals 138. And then we're going to divide by 6. So we get x equals 23. But they did not ask us what x is. They asked us to find the measure of the two angles. So what we're going to do is we're going to go back and plug x in for both equations. So 2 times 23 plus 10, that's 56 degrees. And then this angle, let me just switch colors real quick. This angle right here is 4 times 23 minus 3. And that is 89 degrees. And one check you can do is, you know, together they're supposed to equal 145. So 56 plus 89 is 145. All right, here's example 4b. Let's look for keywords. It says KLM is a straight angle. And what we know about a straight angle is that it is 180 degrees. So it wants us to find the two smaller angles. Well, you know this is a straight angle, so you know all together it equals 180. So what we can say is that we can say the left side, which is KLN, plus the right side, which is NLM, equals 180. So KLM is 10x minus 5, plus NLM is 4x plus 3, and it equals 180. So that setup, that's the geometry part. Now you're back to Algebra 1, where you're just going to combine like terms and solve for x. So now we're going to add the 2. So we get 14x equals 182, and divide by 14. So we get 13. Okay, so they don't want x, they want the angles. So what we need to do is plug 13 back in for x. Using a calculator is a good thing to do, it's not a problem. Plug 13 back into this x, and this specific smaller angle here is 55, which if you double check yourself, 125 plus 55 is 180, so it does check out. All right, so on example C it says, given EFG is a right angle. What does a right angle tell you? All right, it tells you that it equals 90 degrees. So we should know that 2x plus 2, which is EFH, plus, sorry, I should not have done equals there, plus the other angle, which was HFG, equals 90 degrees. So that's the geometry part. So now just work on your solving skills, combine your like terms, subtract the 3, and then divide by 3. And I end up finding out that x equals 29. Now remember, you plug 29 back in, and so on this side I get 60, and I plug 29 in here, and 29 plus 1 is 30. So my answers are 60 and 30 degrees. Okay, ray QS bisects angle PQR. It says sketch this figure. So I don't know how big PQR is. I'm just going to make an angle. It's not drawn to scale. I have no clue how big it is. And I'm going to label it P. Q is in the middle, so it must be the vertex. Q and R. Now QS is a ray that bisects it. So I know bisect means it should be coming down the middle. So it comes from Q, goes through S, and it comes down the middle, and I'm putting those two arcs, meaning those two sides are congruent, because bisects means cuts into two congruent or two equal parts. All right, PQS, that's this angle, is 24. So it's saying, hey, find PQR. Well, if PQS is 24, then SQR is also 24, because bisects tells you they cut into two equal parts. So PQR is the whole angle, and 24 plus 24 is 48 degrees. All right, so I think we're going to go ahead and skip example 6 just for time. We'll be working on more in class, but definitely knowing your vocabulary and knowing what all of the angles are when they say acute, right, straight, obtuse, and when they say angle addition or angle bisector, that will help you a lot. Geometry is really a lot of vocab, and then just applying it to problems that then once you apply it and you set it up, it really just turns into a basic algebra solving problem. So as long as we continue to work on knowing our vocab, we're going to get stronger at this every time we work on it.